Hey everyone, in this video we're looking at measures of spread. So just like the measures of center, this is a statistical piece of information that helps describe the whole data set. So it's like one value and it gives you like an indication of what's going on with the whole set. Alright, so what we're looking at, and as a year 7 student, your main concern is the range. And I've been actually leading you guys up to this in class the last couple of weeks. So here we are. Again, looking at our types of data. This range is generally with these guys because it's to do with quantitative. So max and min, and generally you need to have numbers to do that. So it'll be more of an emphasis on this. Right, determining the range for a data set. It's generally by inspection to look for maximum, minimum, and you guys have been doing that in class. And then you find the difference. So difference, subtraction. There's your formula if you must know, but we're looking for the difference. It's pretty straightforward. Righto, here we go. So here are my numbers. My maximum, 76. My minimum is 12. And write that in. So range equals max minus min, and 76 minus 12 gives us 64. So that's our range. If you did this the other way, it'll give you negative 64. Just remove the negative and you're good. So if you did minimum minus maximum, just subtract the negative and it'll still give you the range. Now, just as a point of understanding of what a range is, if you have data that is really spread out, so say a really good example is the heights of people. So I'm not just talking about students at high school, I'm talking about like everyone. What we have generally is that if this is heights, this being 0 and this being somewhere up near 3 meters, and so that'd be 1, 2. And most humans lie somewhere between here and adult humans lie somewhere in this little patch here. So there's a big flux of us here with more here in this domain, like around that half, 6, 1.5, 1.6, 1.7. And then it starts to taper right off, and you might have very few people who are over 2 meters tall. And then down over here, we actually have quite a lot of people on this side, and that's because people are young and they grow. So we have like this formation of, if we took all the data points and graphed, like if we put a dot plot of like all the individuals that we measured and counted them along the way, you would have like this big cluster here. And this is what we call like the range. So if we have that one, and our range is going to be quite large. Now, if we just took a snapshot of, say, our year 7s, you guys would be somewhere between the 1.3-ish and this point here. And what you'll see is that the range becomes smaller because you're dealing with a group of more likeness. So, and then if you have even like, smaller again and so forth, you might see that those people are of all the same age or something. And a really good one is generally when you do like levels of achievement. So if we looked at our like an extension class, you'll find that the range of scores would be a lot smaller, and therefore the group is more similar than if you did like a range of scores across say the whole of year 7. And then you'll see that there is a really big range of really high and really low and somewhere in between. So it just tells you that there's the closer things are with, the smaller the range, the more homogeneous or the more similar things are. And then the bigger the range, the more different they are. So that's how you can remember like the importance of range. But hey, I like stats. So that's why I'm excited about this. So what you're going to do though, because this is probably one of the easiest statistics to do, it's going to be find max, find min, find the difference. Do a whole lot of finding. So here you are, there are your 1, 2, 3 questions. have a go. Stay awesome. Short and sweet. Bye.